to 2 plus I. Okay? So on this one, we're going to say 2 plus I, which is our 0, our k, and our coefficients are 1, -5, and 1. Bring down the 1. 2 plus I times 1 is 2 plus I. And remember, you can only add and subtract the real parts. So that would be -5 plus 2, which is -3, plus I. So now I need to say 2 plus I times -3 plus I. Doing full method. 2 times -3 is -6. Outside's plus 2I. Inside's minus 3I plus I squared. And what's I squared equal to? -1. So 6 minus 1 will give me -7. And then 2I minus 3I is minus I. So I have -7 minus I. 1 minus 7 gives me -6. And then you've got your minus I. So that's equal to F of 2 plus I by your remainder theorem. Whatever the remainder is, that's equal to F at that, evaluated at that number. You plug it back in. Okay? All right, any other homework questions in 3.2? You got a few here in 3.3 as well. And I think I told y'all the 3.3 kind of included the same stuff, so it's probably a little more important.
51.
On this same section?
Yes, ma'am.
All right, 51. On 51, you're given f of x is equal to 5x to the 4th plus 2x cubed minus x plus 3. And on this one, you're told k is 2/5. So you're asking yourself, is k equal 2/5 of 0? That's your directions. When you know the answer will be yes, it's a 0, if the remainder is 0. If the remainder is not 0, the answer is no. So we have our 2/5, which is what we're dividing by. The x to the 4th, which is your highest exponent, coefficient is 5. Your cubed term is 2. You're missing the squared term, so fill it with a 0, -1, and 3. Notice, 4th degree, you should have 5 terms here. 1, 2, 3, 4, 5. The terms across will always be 1 more than the degree of the polynomial. Bring down the 5. So I'm going to say 2/5 times 5. So my 5's divide out to 1, so my answer is just 2, right? 2 plus 2 is 4. Well, 2/5 times 4 would be 8/5. 0 plus 8/5 is 8/5. 2/5 times 8/5 will be 16/25. Right? -1, which I can write as -25/25 plus 16/25 will give me 9/25. Right? -9/25. So far, so good? And you can do this on your calculator. You can hit those buttons. Now I need to say -9/25 times 2/5, which gives me -18/125. Okay, well we can figure this out, but just let me ask you this question. Is that going to give you a 0?
No.
No, so the answer is no. 2/5 is not a 0. That's going to give you some number. Let's see what number is on 51. 357/125. Either way, not 0.
If we get to like that 3rd or 4th step and we see that it's not going to give us 0, can we just say, okay.
Yes. Okay? Alright, any other ones in 3.2? Alright, well let's go over to 3.3. On 3.3, you had 5 through 21i. So here you were asked, if it was a factor, if you were given the factor, you had to ask yourself, what would make it 0? Divide. And once again, remainder 0, the answer is no. The remainder 0, the answer is yes. The remainder is anything other than 0, the answer was no. Then 17 on through 21, this is the good stuff. This is where it's getting fun. This is where you're given a zero and you're asked to find all three of them. All three factors, all three zeros. If you're having trouble here. Everybody good on these? Alright. Okay, well let me give you, we're going to start out with doing one just like what the homework here has. I hope I didn't give it to you last time. So this is section 3.3 still. Zeros of a polynomial. And the factor theorem. Alright. So let's say if you're given f of x is equal to x cubed plus 7x squared plus 15x plus 9. And I'm going to tell you k equal negative 3 is a 0. We already did this one? Okay, well let me give you another one. Alright, let's go back up here. Let's say if I give you that f of x is, there's something that I did that I liked. Let me cheat and make one up real quick that I want to do. Alright. Alright, so this time we're going to be given an f of x is x cubed plus 2x squared plus x. Oh, hold on. I'm giving you the name file before I combine my term. X cubed minus x squared minus 5x minus 3. And I'm going to tell you k equal negative 1 is a 0. Find your linear factors. And we're going to find all the zeros. Well, first of all, how many zeros is this problem going to have?
3.
3. And you know that because the degree of the polynomial, your highest exponent is 3, so it's going to have 3 linear factors, and it's going to have 3 zeros. So I'm going to give you a minute to finish it out. Find all 3 factors, find all 3 zeros, just like you did on your homework. I got this one done. Alright, so you did, if negative 1's a 0, you do your synthetic division of negative 1. This is an x cubed, which is 1, negative 1, negative 5, and negative 3, right? Bring down the 1, negative 1 times 1 is negative 1.
I looked at all kinds of
You got negative 2, negative 1 times negative 2 is positive 2. You get negative 3, negative 1 times negative 3 is positive 3. So you got a remainder of 0, which we knew that was going to happen. F of negative 1 equals 0. So how would I write the factor? Negative 1 is a 0. How would the factor be written?
I thought it's supposed to be 1, positive 1.
I thought we changed the one.
No. You only change it if it's written as a factor. Remember, if it gives you the actual, you always divide by the 0. You always divide by k. The only time you would change it would be if I ask you there is x plus 1 a factor. You would you'd say, okay, what makes this 0? Negative 1, and that's what you divide by. The only time you change that sign is when it's written as a factor.
Oh, okay.
Just like we're going to get ready to do here. If negative 1's a 0, how would I write the factor? X plus 1 would be a factor, right? Because if you put negative 1 in here, you get 0. It's always the opposite. It's always x minus the 0 is how you write the factor. So right now, I can say this function f of x is equal to this factor, x plus 1, times the answer I have. If this is an x cubed, what's this 1 the coefficient of?
X squared.
X squared minus 2x minus 3. You have a quadratic equation, which you know how to solve, either by factoring or by doing quadratic formula. This one actually factors, so we'll factor it. This will factor into what? X minus 3 and x plus 1, right? So up here for my linear factors, what do you notice here with these x plus 1s? You have x plus 1 times x plus 1 times x minus 3. X plus 1 is a factor how many times? Twice. But if you wanted to, you could write the 0 here both twice. But what this is called, when you have a 0 twice, it's called multiplicity. Okay? So when that's what we're getting into now. If we're talking about zeros of multiplicity, it means that 0 happens more than one time. If you, like on this one, I'd say negative 1 is a 0 of multiplicity 2, because it's a 0 twice.
Okay. So we do have to write it there. We do have to put it.
Yes, if you had to, this is a 0 2 times. If you didn't write it negative 1, your other option would be if you said negative 1 in parentheses, you put multiplicity 2 and 3. Most times it's just easier to write it twice. Because it is a 0 3 times.
Okay.
And I want to look at how this affects our graph. Once again, you know this is an x cubed. So you know this graph basically looks like this, right? But of course, if we got all this extra stuff going on, it's going to have more humps, a few more humps in there. But my zeros, negative 1 and 3 here, those are my x-intercepts, just like they are in 3-1 with the parabola. Okay? And we're going to see here, when you're looking at a graph, when you're looking at the graphs, and a lot of you, I'm not going to make you do a graph on the test, but if you have a graphing calculator, this is a handy tool to help you figure it out. If it has an even multiplicity, if your 0 happens an even number of times, it will just touch the graph there. But if it has an odd multiplicity, like 3 is an odd multiplicity, it's a 0 one time, it actually is going to cross the x-axis at that point. So let's this is when we're going to kind of write this little definition here. So you're told here, zeros of multiplicity tells you the number of times that number tells you the number of times that number is a 0 for f of x, or of f of x. So zeros of multiplicity lets you know that that number, like on that one, negative 1 is a 0 of multiplicity 2. Negative 1 makes that function a 0 twice. And we're going to have to things with multiplicity 3, most of the time it's 2. But 0 is a multiplicity. And the way this is going to help us is you can have now, so far we've done x cubed, third degree polynomials. If you need 1 0, you got down to an x squared, which you could solve. Now we can have a fourth degree. And if you're told about multiplicity, you can do synthetic division twice to get down to an x squared. So you'll be able to work it. Let's look at that graph. Alright, so we're look x cubed minus x. Alright, so we look at this graph. You see, this will look, see, it's your basic cube graph. It starts down, ends up. But notice right here, at -1, where it touches the x-intercept, it just touches it, because that's an even multiplicity. That 0 is a multiplicity twice. So it touches it there, but then you see here at 3, it crosses it. So it's showing you all 3 zeros. It's touching it here. So that -1's a 0 twice, and the 3 would be a 0 once. You with me? And then you have to wait till you get into, like, take a calculus class to actually know that value there on your graph. So that's why it would be a rough sketch. Alright, so now let's look at how this is going to help us. So if we have a problem like, let's say we're given f of x is equal to x to the 4th plus 4x cubed plus 3x squared minus 4x minus 4. And here we're told k equal -2. And it usually is written this way. It'll have in parentheses multiplicity 2. Okay? And once again, you're going to list your linear factors. We'll list our linear factors. And how many will they be on this one?
4.
4. And then you'll list all 4 zeros. Alright, well let's talk a minute. If -2 is a 0 twice, what's going to be your factor that you're going to see twice?
2.
X plus 2 will be
X
the
plus
factor,
2.
right? If -2 is a 0, then you're going to have x plus 2 is twice. Your factors are at least going to be x plus 2 and x plus 2. Do you agree? Alright, let's start working this. So I'm going to do -2. This is an x to the 4th. That's going to be 1, 4, 3, -4, and -4. Before you jump to start doing, I want us to talk about something. We'll use a little common sense. When I do the -2, divide by it, what's this row going to be? Remember it goes down in power? So this will be an x cubed row. We still don't know how to factor an x cubed row, but since I know -2 is a 0 twice, I'll be able to use that second -2 into my x cubed row, which will get me down to an x squared row that I can solve by factoring a quadratic formula, right? So whatever your degree is, so you can subtract 2 from it, and that's how many times you're going to have to do synthetic division to get down to your quadratic row. So let's do this one. Bring down the 1. -2 times 1 is -2. 4 plus a -2 is 2. -2 times 2 would be -4. -1. +2, -2, +4, 0. Right? So like we just saw, which we knew was going to happen, f of -2 equals 0, x plus 2 is a factor. And I write that every time. Okay? Now, like I said, this is the coefficient of x cubed. Right now, you won't have to rewrite this every time, but we can say f of x is now equal to x plus 2 times x cubed plus 2x squared minus x minus 2, right? If I multiply that through, I'd get my original. But now we got to break this down. We got to get this down to an x squared. Okay, so we're going to use the fact that -2 is a 0 twice. So I'm going to come up here, I'm going to do -2 into this x cubed row, which is 1, 2, -1, and -2. And you'll always keep doing this with these zeros till you get down to an x squared. So we're doing it, that's the coefficient of the x cubed part. 1, 2, -1, -2. This row right here. Because this was my x cubed row. So do quadratic equation, do synthetic division here. Bring down the 1. -2 times 1 is -2. 0. 0, -1, +2, 0. So once again, f of -2 is 0. So there's that x plus 2 being a factor twice. That's what the multiplicity meant. So now I can say that my function f of x is equal to this x plus 2 factor, the x plus 2 factor we just found here. If that's an x cubed, that's the coefficient of x squared. So this is x squared minus 1, a quadratic. That you know how to factor, right? How do you factor x squared minus 1? Difference of two perfect squares factors into x plus 1, x minus 1, right? So now you have completely factored that huge fourth degree polynomial.
How'd you get x squared minus 1? Where you get?
Right here, this is the coefficient, this is the x cubed, it goes down a power, so that's the coefficient in front of x squared. There's not an x term, and then the constant's -1, so it's x squared minus 1, which like I said, factors into x plus 1, x minus 1.
So every time whatever our number is, whatever k is, we do it on both.
Well, it depends on what it tells you about multiplicity. If it tells you multiplicity 2, yes, you'd use that same number twice. We're going to learn as we get higher into chapter 3, you're going to be able to find your own zeros and know what to pick. They won't always be the same number. You're going to really like it when it says multiplicity 2, because you're going to know what to use twice.
So your linear factors just come from that second.
Yeah, it comes from completely factoring this out. Those are your 2x plus 2s that you found here and here. And then this bottom row, that quadratic, factors into the difference of squares. So now you can say your 0. What made this one 0?
-2.
-2. Of course, your negative, that's multiplicity 2.
-1.
-1, +1. So you see all 4 zeros. All right? Find. All right, next. We'll lead us into an example that's going to get us to our next one. All right, this is going to lead us into our next topic. I'm just going to be talking about complex zeros, and we'll show you why it works and why the definition is what it is. This kind of goes back to what you did for homework today. If you were given f of x is equal to x cubed minus x squared plus 3x plus 5, and you're given that k equal -1 is a 0. You're going to find the linear factors and the zeros. Do our synthetic division. How many zeros is this problem going to have?
4.
How many?
3.
We're going to do our -1. What we think is the 0. We always divide by the 0. This is your x cubed. This is 1, -1, 3, and 5. Bring down the 1. -1 times 1 is -1. Get -2, +2, 5, -5, 0. So if f of -1 equals 0, what will be the factor?
X plus 1.
X plus 1 is a factor. Alright? So now I can write this function as x plus 1 when is x squared minus 2x plus 5? When does that, how am I going to solve this equation?
Make, oh, you made it.
Quadratic formula? Remember you solve quadratic equations by factoring, square root property, quadratic formula. Could do complete and square, most people don't. Alright, so let's plug in here. So my other two zeros, to find out what makes this zero, that'll be when x is a negative 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is 5, all over 2a, which is 2 times 1. So this gives me positive 2 plus or minus the square root of 4 minus 20 over 2, or 2 plus or minus the square root of negative 16 over 2, which is 2 plus or minus 4i over 2. Remember doing all this? Test 2? Maybe test 1? I think that's 2. So now we split this up, 2 over 2 plus or minus 4i over 2, so I get 1 plus or minus 2i, right? So far so good? You remember solving quadratic equations by quadratic formula when they didn't factor? Alright, now let's write our zeros. So my zeros, I found this 0 is negative 1. This, well, I've got a 0 here of what? 1 plus 2i and 1 minus 2i. That's my three zeros. This 0, negative 1, which was this factor. Then I had to solve this one because it's not factorable by the quadratic formula to get the other two zeros. Yes? You understand why we had to do this one that way? Because this does not factor. My quadratic row does not factor, but you can still find zeros whether it factors or not. Well, before I come back to factors, let's look at this. What do we call these in complex numbers when you have exactly the same things but the signs were different? Close. Something with a C? Conjugates. These were called conjugates of each other. And one thing about complex zeros is anytime you have a complex zero, you're always going to have the conjugate that's going to be a 0 too. Because anytime you get a complex zero, like what we saw earlier with that x squared plus 4, they got that plus or minus 2i's as zeros. You got positive 2i, you got negative 2i. Those are conjugates. Here, these are conjugates. 1 plus 2i, you can't have 1 plus 2i without having 1 minus 2i. Because when you do the quadratic formula, what's right here on the quadratic formula? Plus or minus. So anytime you do the quadratic formula, you're going to end up with that plus or minus, which means these complex zeros will always come in conjugate pairs. Now to write your factors here, you know that one was x plus 1. Now we're not going to get real tricky on these. Remember I always said you write a factor, x minus the 0. So you're going to say x minus, and put in parentheses, 1 plus 2i. X minus, in parentheses, 1 minus 2i. I don't want you worrying about distributing the negative or anything. Just write it as x minus the 0. The way you write all your factors. All factors are written as x minus the 0. Remember this would be x minus a negative 1, which is where you got the plus 1. If you're smart enough to know that it's the opposite. Alright, are we okay here? Now I'm going to show you how this is going to help us. This problem is going to help us because we can now say, by definition, which is on that note sheet that I gave you, that complex zeros, and also irrational ones, but we're not going to deal with those. We're going to say that complex zeros always come in conjugate pairs. That means if you are given, say that 2i is a 0, then negative 2i is also a 0. Or like on this one, if 1 plus I is a 0, then that means 1 minus I is also a 0. You follow what I mean by conjugates? And this is also going to help us when we have a fourth degree. Alright, so let's look at one of these. based on this, now if I give you an example, say if I give you that f of x is equal to x to the fourth plus 4x cubed plus 4x squared plus 4x plus 3. And I'm going to tell you that k equal I is a 0. And then you're going to do the same thing we did before. We're going to list all linear factors, and we're going to list all the zeros. First off, how many zeros is this one going to have? 4. Okay. Well, I know when I divide by I, it's going to get me down to an x cubed. So you have to know another 0 to be able to get you down to an x squared. But because you're given a complex 0, if I is a 0, what else has to be a 0?
Negative I.
So k equal I is a 0, then negative I is also a 0, because they have to come in conjugate pairs. Right? So let's do it with I. This is probably going to be the worst thing on your test, is this problem right here. Okay, you got an x to the fourth, which is 1. Your cube coefficient is 4, 4, 4, and 3.
I got a question. How
Okay.
are we gonna know on the test by looking at them which ones are gonna be the conjugate pairs and which ones
If it
are?
has an I, it's a conjugate
It's a
pair.
conjugate,
Okay.
period.
Right.
So whatever has 0 right out beside it, we never change.
No, you only change the sign if it's written as a factor. Like if it's got an
X
x,
plus one.
x plus something or x minus something with it. Is the, and that'll only be on the first one, it's like synthetic division in 3-1, and it'll be if I ask you, is x plus 2 a factor? Most of the time, you're going to be given I as a 0. You all think in your mind, you always divide by the 0, and you're assuming k equals a 0. So bring down your 1. I times 1 is I. Now these aren't like terms, so I cannot add them. So it's going to be 4 plus I. Now on these problems we're getting ready to do, this first one is going to be messy, kind of like the ones you did for homework for today. The second one, when you divide by the conjugate, that one's real easy because all the i's are going to go away on those every time. Now let's multiply. We've got to say I times 4 plus I. Using distributive property, I get 4i plus I squared. And what's I squared equal to? Negative 1. So that's actually negative 1 plus 4i. Now we can add 4 minus 1 is 3, so that gives me 3 plus 4i. Now I need to say I times 3 plus 4i. Using distributive property again, that gives me 3i plus 4i squared. We just said I squared is negative 1, so that's 4 times negative 1, which gives you negative 4 plus 3i. Remember, you always write the real part first. Now 4 minus 4 is 0, so I'm just left with 3i. Now if I say I times 3i, I get 3i squared, so that's 3 times negative 1, which is negative 3. So you do get your remainder of 0. So I can say that f of I equals 0, so x minus I is a factor. Okay. If this was the x to the fourth, what's this the coefficient in front of? What row?
X cubed.
X cubed. Which this is what we're going to use our negative I with. So we're going to do synthetic division with that I, with negative I, with this x cubed row. My x cubed coefficients are 1, 4 plus I, 3 plus 4i, and 3i. We know when we do synthetic division here, I'll end up with an x squared. So bring down the 1. Like I said, this one's going to be easy because your i's subtract out every time. Negative I times 1 is negative I. So you're just left with that 4. Negative I times 4 is negative 4I. So those I terms subtract to 0. You're just left with 3. Negative I times 3 is negative 3I. So you get that remainder of 0. So we can say that f of negative I equals 0. So x plus I is a factor. Right? So now I can write this function as f of x is equal to x minus I times x plus I times this row here, this x squared plus 4x plus 3. So we kept dividing until we got it down to this x squared row. Now, can I factor x squared plus 4x plus 3? Are there factors of 3 when you add that give you 4?
3 and 1.
3 and 1. So I can write my linear factors as x minus I times x plus I times x plus 3 times x plus 1. So you see your zeros are I, negative 3, and negative 1.
I don't understand how you got f of x.
Ooh-wee.
Right here?
Yeah.
Alright, the whole reason for doing this is because once you find a factor, you can break this down. That's what we're trying to do. We're trying to find all the factors, the 4 factors that I would need to multiply together to give me that original back. So when you get a remainder of 0, it means that that's a 0. Let's look at this one right here. On that last test, on test 1, if I'd have told you to solve this, to find the 2 zeros, you would have factored it, right? But like what we just did. And you know this is factored correctly because if you did 4, you'd get your original back, right? We're doing that same thing to this 4th degree polynomial. But in order to find these zeros so that we can factor it, we're having to do this synthetic division. Because we don't know how to break down that big 4th degree just like we did this. But every time we get a remainder of 0, we get a factor. If the remainder is 0, then x minus the 0 is always a factor. So that's why x minus I is one of the factors. So then I could write this, which I didn't here because these coefficients are so ugly. But I could have wrote it as x minus I times x cubed plus 4 plus I x squared plus 3 plus 4I x plus 3I. But of course I have no idea how to factor that either. That's x cubed. So we use the conjugate, the negative I, into that x cubed row to get me down to an x squared. So that when I go to write it, you got to go back here. That's why you write this down every time, so that you can write your factors. That was the first factor. This was the second factor, the x plus I. And of course, I can factor this right here normally, because it's a quadratic equation.
So that's just right down there, right?
Yes, this is just that bottom row, because that was x cubed.
Okay.
All right, we good there? All right, so that gets us to our complex zeros. Now we're going to talk about your rational zero theorem, which is on that handout. The handout that I gave you, it kind of jumps down a little bit. It says the rational zero test. It gives you all the possible zeros. So this is where things are going to really start to get fun. So far, every problem you've had, you've been given a 0. You've had a starting point. You're going to start having to find that 0 on your own. Okay? I want us to look before we do it something. Okay, when you were given this equation, and you're told to find the zeros, which of course this 0 is negative 3, this 0 is negative 1, right? When you're going through and doing this, do you agree that whatever your answer is here, well, let me give you a different one. Let's say if I have, let's say if I have 6x squared plus 5x minus 3. I don't look at my cheated. All right, let's say if you were going to do this one, find the zeros. So you would factor. 6 has got your 2x and the 3x. Well, let's see if we put the, I might have got a little messed up here. All right, let's make this a 7. Should have worked. All right? So let's say if I put the 3 here and the 1 go and solve. What do you notice here? Do you agree that this 3 here is a factor of this constant number? And of course, 1 here is also a factor of that number. You agree there? Even over here on this one. My answer here, 3 and 1 here are both factors of that constant number. Do you agree? These numbers in the numerator, they're factors of this constant term. And notice these numbers in the denominator, 2 and 3. Do you agree those are both factors of that leading coefficient? And it works that way every single time. Here, these denominators are understood to be 1. And the only factors of 1 is 1 times 1. So those denominators are understood to be 1. But whatever's in your numerator has to be factors of the constant. Whatever's in the denominator has to be factors of the leading coefficient. On quadratics, on everything. So by this rational zero test, it's going to help me find all the possible zeros by using that terminology there. Okay, so your the rational zero test is going to gives you all the possible zeros. That possible is a key word. If I tell you it's possible that we might have another quiz on Thursday, does that mean we're going to have one? No. So it means we might or we might not. And that's what this rational zero tells you. It's going to give you the possible zeros. Some of these zeros will work and some of them won't work. Okay? But you can't have a zero unless it's in that group. Okay? So what you're told is if your possible zero test is called plus or minus P over Q, where P is factors of the constant term. And Q is factors of the leading coefficient. So you got this plus or minus. You got to take into account the positive and the negative of each one of them. So before we do a whole problem with it, let me show you what we mean here. Okay. So let's say, for example, number 1 here, if you're given that f of x is equal to 8x to the 4th minus 3x squared plus 2x plus 2, and you're just asked to find all the possible zeros. Okay, so on this one, what is my P here? 2, and the Q is 8. Well, let's write over here. What are factors of 2?
How do you know that 8 is Q and P is 2?
Okay, because P is always the factors of the constant term. P is always constant term. Q is always the leading coefficient.
Oh.
Okay, so P is 2. So factors of P are 1 times 2. Okay, Q is 8. My factors of 8 are what? 1 times 8 and 2 times 4. So when I write my possible zeros, plus or minus P over Q, I want you to listen. We got to put every P over every Q. So you start with 1. What's 1 over 1 equal to? 1. I just go straight through. What's 1 over 2? 1 over 2. 1 half. What's 1 over 4? 1 4. And then 1 over 8 is 1 8. So you put the first factor of P over all those Q's.
So why is the 1 like that?
Because 1 over 1 is 1.
I'm sorry.
Okay? Now go to 2. 2 over 1 is 2. 2 over 2 is 1, and it's already there. 2 over 4 is 1 half. It's already there. 2 over 8 is 1 4th, and it's already there. Okay.
So I would just write them all out and then we know what we do.
Okay. So you start with your factors of P. You put your first factor of P over each factor here. Okay? So that would be 1 over 1, right? Then I'd have here 1 over 2. Then I'd have 1 over 4. Then I've got 1 over 8, right? Go to the next one. 2 over 1 is 2. We got 2 over 2. You got 2 over 4. And we have 2 over 8.
Okay. Yeah.
Okay?
Yeah.
But now look what happens. What's 2 over 2 equal to? 1. What's 2 fourths equal to? 1 half. What's 2 eighths equal to? So they're already there. Now look at this list. It's plus or minus. So that means my possible zeros for this could be positive 1, negative 1. Positive 1 half, negative 1 half. So you've got 1, 2, 3, 4, 5, 10 possibilities. You have 10 possible zeros. And what you're going to have to do is you're going to start doing synthetic division. You're going to keep doing it until you find at least 2 of them before you get down to a quadratic. Okay? So let's look at a problem where we're going to do this. And where did I just find that key? All right.
So that's just the answer.
That's,
Yeah, because all I'm asking you there is to find the possible zeros. We're going to show you how you're going to use it. So the way you're going to do this is going to be your Mac Daddy problems. It's like this. F of x is equal to 2x cubed minus 3x squared minus 11x plus 6. Okay, this is going to be the template like I give you on the test. I'll ask you for the total number of zeros. I'm going to ask you for the possible rational zeros, which is what we just did. And then I'm going to ask you for the linear factors and for all the zeros. And we're going to learn a few more things that's going to help you narrow your possible zero list down. I don't know if we'll have time to get to those today or not. We'll see. And write this template down because for homework in a little bit, we're going to do a couple more of these examples, and I'm going to give you 2 or 3 problems out of the book, not many. And then I'm going to write some more problems just up on the board that I want you to do the same thing. Because some of the problems in your book get to be way, way big, and we're not going to go. I don't want you wasting your time on all that. Are we ready? What's the total number of zeros this is going to have?
3.
3. Possible zeros. What's my P in this problem? 6. My factors is 1 times 6, 2 times 3. What's my Q in this problem?
2.
2. So my factors are 1 times 2. So my possible rational zeros is plus or minus . Ready? 1 over 1 is 1. 1 over 2 is 1 I've used the 1 and I've used the 2. Now go to the 6, or 3, let's go to 3. 3 over 1 is 3. 3 over 2 would be 3 halves. So I put 3 over both of them. Now go to 6. 6 over 1 is 6. And what's 6 divided by 2?
3.
3, and it's already there. Okay? So it's the positive and the negative of these numbers. So that means we have here what? 2, 4, 6, 12 possible zeros. Out of these 12, 3 of them, the 3 are your zeros. For this one has all real number zeros. There's not going to be any complex ones. They're in there. Okay? So our 3 zeros are one of those 12 numbers. And the way you're going to find them is you pick one and you start doing synthetic division and you hope you get a remainder of 0.
Really?
Okay. And now listen, probably next week, what's today? Today's Tuesday, right? Thursday, I'm going to help you narrow down your search. Okay? But I don't want to throw too many definitions on you at one time. Alright, pick a number out of this list. Anybody pick a number?
2.
2. Alright, so let's start with 2. We've got our x cubed, which is 2, negative 3, negative 11, and 6. Bring down the 2. 2 times 2 is 4. 1, 2. Negative 11 plus 2 gives me what? Negative 9. This gives me negative 18. That didn't work.
Right.
Alright, pick another one.
3.
3. Okay? What about while I'm picking 3, somebody else pick another one and see if you find one that works. Picking 3 though. We've got 2, negative 3, negative 11, and 6. We only have to find one that works, and then it'll be a quadratic that I can solve, right? So it's just finding that one that works. So bring down the 2. 6, 3, 9. Negative 11 plus 9 gives me what? Negative 2. 3 times negative 2 is negative 6. So we got that remainder of 0. So that's what I told you earlier on. When you get a remainder of 0, you're going to feel like you struck gold. Alright, so we can say that f of 3 equals 0. So what's the factor?
X minus
Minus 3 is a factor. So now I can write this function as x minus 3 times, this is coefficient front of x squared, times 2x squared plus 3x minus 2. Which I can continue to factor. We want it to be a positive 3, so make that 4 minus 1. Right?
So where did that x minus 3 come from?
Say that again.
That x minus 3.
Because if 3 is a 0, then x minus 3 is a factor. Alright? So we can come back over here and we can write these 3 factors. X minus 3, the one I found. 2x minus 1. And x plus 2. So my zeros are, what made this one 0?
3.
3. What makes this 0? 1 half. And negative 2. Right? Alright, let's look at another one. Alright, we're going to up it. We're going to up the ante. We're going to try a 4th degree. Alright, I'm going to make this one's going to be almost 2 equal. When your leading coefficient is 1, it's going to make the problem super easy because that means all the denominators are going to have to just be 1, right? So for this next example, let's say we're given f of x is equal to x to the 4th minus 2x squared minus 16x minus 15. Almost was 96. Alright, what's my total number of zeros?
4.
4. Possible zeros. What's my P in this problem?
Negative.
Alright, you'll always, since you're putting that plus or minus, just use the positive, because you're going plus or minus is going to take care of that sign regardless if it's positive or negative. So just say P is 15, so that's 1 times 15 or 3 times 5. And Q would be 1. So that factor is just 1. So your possible zeros is plus or minus. 1 over 1 is 1, 3 over 1 is 3, 5 over 1 is 5, 15 over 1 is 15. So it's, you got 8 possibilities here. Alright? Since we're running a little low on time, let's start out picking -1. Okay? Let's do -1 first. Now, like again, you might have tried something that didn't work first. But let's try this -1. Now, this is an x to the 4th, which is 1. Ooh, what do I pick for our next one?
0.
0. Don't ever forget to fill in those missing terms with a 0. Alright. Bring down the 1. -1 times 1 is -1. 0 plus -1 is -1. -1 times -1 is 1. -1, 1, -15, positive 15, 0. So f of -1 equals 0. So what will be the factor, Macy?
The factor will be x plus 1.
X plus 1. Good. You know where that comes from, right? Now that was an x to the 4, so that means this is the coefficient in front of x cubed. You don't have to keep writing that f of x thing every time. You know you're going to have to divide again because it's an x cubed. Make life a little easier, we're going to try 3 this time. So that's 1, -1, -1, -15. So bring down the 1. 3 times 1 is 3. 2, 6, 5, 15, 0. So f of 3 equals 0. So x minus 3 is a factor. Alright, here's where you're not going to like it. Because what do I have here? This is now x squared plus 2x plus 5, which does not factor. Which means we are going, it's actually, do you agree this is the same quadratic equation I gave you earlier? You remember we solved it a few minutes ago in the note? And we found that when you do quadratic formula, x was equal to -1 plus or minus 2i. We did that exact one on another example. Alright, so linear first of all, zeros. I have 2 complex ones, but I have 2 real ones, the -1 and the 3. Then I have -1 plus 2i, -1 minus 2i. So let me show you how to write the factors. Factors, it's always the opposite, x plus 1, x minus 3. This will be, since there's 2 terms, it'll be write it as x minus a 0, in parentheses, -1 plus 2i, x minus -1 minus 2i. So that would be your answer there. Alright, now let me give you some homework problems. We still hadn't finished 3-3. Alright, so next, on 3-3, you can do problems on page 338. I want you to do numbers 27, 27 through 33 odd. Then I want you to do well, actually let's just say 27 through, hold tight, 41 on it. And I won't give you the extras. So do 27 through 41 on it. That's not very many. Make sure you do those. return your test and I'll give you a bonus. And it's a 5th degree polynomial.